Hi students, today we are going to see electron dot structure. Chemistry is easy when we understand and learn, right? Why do metals and non-metal react? Metal and non-metal react to form a stable octet configuration. See, anything in nature attains stable configuration means it attains a state where it has a low energy level. Okay. Any substance element tries to attain stable state, lowest energy state. Okay. So that is natural. Anything is striving to do something. It means it is trying to attain its lowest energy state. Then it is a natural process. Then it is a spontaneous process. Okay. So the octet configuration is the lowest energy state of element, metal and non-metal. So for any element, the octet configuration is the lowest energy state. Okay. Until it is attaining that, it will strive to do that. Okay. So metal and non-metal, they react to attain this octet stable state configuration. Only because of that, chemical reaction take place. There is a movement of electron from one place to another place or sharing of electrons. Okay. Okay. Now let us see how they react. Let us take sodium metal and chloride non-metal. Okay. So atomic number of sodium is 11 and its electron in shell is KLM 281. Okay. And for chlorine it is 17 and it is 287. See here, to attain the octet configuration, sodium can lose this one electron which is in M shell. Okay, if it loses, it turns out to be octet. And chlorine, you can see, it is one shortfall of electron to achieve the octet. Either it can lose 7 electron or it can take 1 electron, which is easy. Taking 1 electron is easy than losing the 7 electron. So it will try to take 1 electron which sodium is ready to give. Okay. When these two come closer, this switchover take place. So after reaction, what happens? Sodium has 2, 8, 10 electron. Okay. And chlorine has 2, 8, 8, 18 electron. So this is stable state for both the case. Okay. Since sodium is losing 1 electron, it forms sodium ion, Na plus ion. It is called as cation. Okay. So, any element which carries a positive charge is called as cation. Then for chlorine, it takes up 1 electron and forms chloride ion. It is chloride ion, it is anion. Okay. It receives the electron. Here electron is released. Here electron is received, one is giving, another one is receiving. We can express this electron in electron dot structure. Okay, we have sodium having the outermost electron alone is represented in electron dot structure. So sodium in M shell has 1 electron. Okay, it is a dot, and chlorine in M shell has 7 electrons, so it is represented as in 2 marks. Okay, so now this 1 electron from sodium shift to here to make it octet. Since it has given 1 electron, okay, it takes the positive sign because it has 11 proton and 10 electrons. So net charge on the sodium will be plus. Okay, 1 electron shortage, so net charge on the sodium will be plus. And chloride, it has 17 proton but 18 electron. So net charge on chloride will be minus. Okay. They will be very close to each other because polarity. This is positive, this is negative. So we call this force of attraction as electrostatic force of attraction. So they bind them together. Sodium and chloride are closer to each other because of electrostatic force of attraction. Attraction due to positive ion and negative ion, we call it as electrostatic force of attraction. So these compound formed due to electrostatic force of attraction is called as ionic compound. Okay. So here proton for sodium is 11, electron 11, but for sodium plus proton is 11, electron is 10. So net charge is 1 plus. Okay. So here it is 1 plus. Chloride 17 and electron 17 for chlorine. For chloride for chloride 17 and but number of electron is 18. So net charge is negative 1 minus. Okay. Let us see some more example to understand this electron dot structure. We have MgO. Okay. So for magnesium it is 12. So electron distribution is 2, 8, 2. Okay. And here magnesium can lose 2 electron to attain the octet configuration, right? And in oxygen it is 8, so it is 2, 6. It needs 2 electron to attain the octet configuration, right? So it is needing 2, a magnesium can give 2. So both the transfer will take place. How to represent as electron dot structure? Yes, we have here. See it in close up. So magnesium 2 dots, oxygen we have 6 dots. Oxygen we have 6 dots. So 2 dots from there will come here. So since magnesium has given 2 electrons, so it turns out to be magnesium 2 plus, and oxygen gains 2 electrons, so it turns out 2 minus. So these two are held together by electrostatic force of attraction. This is magnesium ion and this is oxide ion held together. So it is a compound. Okay, magnesium oxide compound is formed because they are held together. In equation, if we write Mg giving you Mg2 plus 2 electron. So O plus 2 electron giving you O2 minus. So what is it? Mg plus oxygen giving you MgO. Okay, let us take one more example. Na2O. So sodium 11. We know 2, 8, 1. Oxygen 8, 2, 6. Oxygen needs 2 electron, but sodium can give 1 electron. So what can be done? So we can think the other ways. 2 sodium can contribute 1 electron to oxygen. Yeah, see the electron dot structure. So 2 sodium is there and 1 oxygen having 6 electron in outermost. So 2 electron loses 1 electron. So they turn out to be Na plus. So 2 Na plus. Okay, and having this oxygen with 2 electrons from 2 sodium. Okay, gaining a 2 minus sign. So they are also electrostatic force of attraction. This 2 Na plus turns out to be in the formula Na2O. We can see the formula here, Na2O. Okay, so in equation form we can write 2 Na and 2 Na plus 2 electron. Why 2 Na? Because oxygen needs 2 electron. Then only that will get satisfied. So 2 sodium has to come closer to oxygen. Okay, oxygen takes up that 2 electron and forms the compound Na2O sodium oxide, disodium oxide. Okay, I think so I made things clear. Okay, electron dot structure. Thank you. Keep smiling.